Hello everyone, myself Salvadis Rujan from Gokaraju Rangaraju Institute of Engineering and Technology from the Department of Electronics and Communication Engineering. Today I'm going to present about our project which we had done in our college. The title of our project is Revolutionize Seating Posture using SVM algorithm model and image processing. Under the guidance of Dr. G. Mamata Samson and my teammates are Dudal Ishwar and Kancharla Kil. So today the contents of our PPT are introduction, literature survey, problem statement, existing work, objective, block diagram, proposed techniques, results and observations, conclusion, and references. Coming about introduction. Nowadays, people are unaware of their sitting postures. According to the research, around 50 lakh people in India are working in the IT sector, which requires them to continuously sit for hours at one place. The National Institute of Neurological Disorders and Strokes claims that most common job related disability is back pain. Sitting in a slouch posture can damage the spine. It is suggested to maintain a proper posture when sitting in an office chair such that it reduces the back pain. With the help of a smart ergonomic chair, which gives the assistance back support that can be improved but will not stop the back pain unless the proper posture is used by the user. In order to get a proper line of sight with the monitor, the office chair should be adjusted according to the height of the person. A proper posture includes sitting in an office chair in a correct posture, which is the best posture to avoid the back pain. Coming to the literature survey of our project, we have we have collected the different conference papers from the IEEE. In that, the first paper is the very similar to of our project. So the title of the paper is an ergonomic chair with Internet of Things technology using SVM. And its problem statement is currently office syndrome is one of the crucial problems since people have to sit on the chair for a long time. The methodology which they used in this paper or in this research, they proposed smart IoT chair that can classify sitting posture. Artificial technique was adapted to this research to classify sitting posture, and the results which they obtained from this paper or preliminary results shows that their smart IoT chair combined with their case study smartphone application can detect five sitting postures accurately with an accuracy of 96.2%. So these are the rest of the papers which we collected from the IEEE. So this is the smart ergonomic chair which we can see in the picture. The problem statement of a project is sitting is the most common status of modern human beings. Many people are sitting with bad posture, which may lead to postural pain, especially for people with short term disabilities. Sitting in the right posture is very important. In this research, we propose a posture recognition system on an office chair that can categorize different health related sitting postures to prevent harm from bad sitting postures. Coming to the existing work, first of all, the data collection. There are different sitting postures, including hunchback, kneeling, reclining, and ideal posture. The sensor readings are sent to the cloud server for every 45 seconds. Each sitting posture was timed for 4 minutes. 10 participants, 7 men, 3 women participated different sitting uh, participated and practiced different sitting postures as part of the study. Coming to the pre-processing of the data, this is an important step in machine learning and also in the existing work method. After participant data collecting is finished, the anomalies are detected and they are deleted. The data is clean and it is made suitable for machine learning. In order to reduce data duplication, data processing enhances data quality and removes extraneous data. Current sitting, correct sitting postures are indicated in the data set by 1 and wrong ones by 0, respectively, in a new column. XVM model training and testing. The XVM model is trained by using 75% of pre-processed data and 25% of the leftover, which is used for testing. Coming to the working, the model is tested for real-time application using the latest data from the cloud. The results which they are obtained by SVM algorithm model is the system is able to identify the wrong sitting postures from different standardized sitting postures. The objectives of our project to develop a smart ergonomic chair with 4 sensors and an IoT interface that can accurately detect poor sitting postures. To develop an SVM algorithm model and image processing techniques that can classify different sitting postures based on the 4 sensor signals and camera images. To evaluate the accuracy and reliability of the developed algorithms in classifying sitting postures. To provide real-time feedback to the user on their sitting posture through the IoT interface and visual feedback. To investigate the effectiveness of the developed solution in promoting proper sitting postures and reducing the incidence of adverse health effects associated with poor sitting postures. To explore the potential of integrating the developed solution with other health related applications such as fitness trackers or health monitoring systems to provide a more comprehensive health management solution. To assess the cost effectiveness of the developed solution in comparison to other commercial ergonomic chairs available in the market. The proposed method uh, in which we used uh, the proposed method tells is this uses the open post model which was invented by CMU Perceptual Computing Lab. It detects the key points of the human body. These key points coordinates are used to estimate the seating posture of the user. Key points relate to each other which with lines, and by using the angle between these lines, wrong sitting posture is determined. There is no need to train the data in this method, unlike the existing method, because the camera sensor used to detect the wrong sitting posture. Open post model determines the wrong sitting posture with the angle made by the lines. If the If the back angle is less than 70 degrees, then the user is in hunchback position. If the back angle is more than 110 degrees, then the user is in the recline position. If the leg angle bends less than 60 degrees, then it is kneeling position. The results which we are obtained from our proposed method are using image processing. The optimized result is given in the form of a pop-up message on the monitor screen of a user. So These are the different wrong sitting posture which I mentioned earlier. One is recline position, which you can see in the figure 1, and other is kneeling position, and the other is hunchback position. This is the a proper standardized sitting posture which should be followed by the user in order to avoid the back pain. Coming to the block diagram of our project. Here we used a microcontroller, Arduino Uno, which is connected to the regulated power supply, and an LCD screen which can display the sensor readings. And we used 4 sensors to detect the force which is applied, force and pressure which is applied when a person sits on the chair. And we also used a Wi-Fi module to connect to the cloud via mobile. Coming to the observations and results. Around 1,000 samples are collected from 4 sensor readings, which are attached to the smart chair. Four force sensors are attached to the chair. One to the backrest, two to the seat, and one to the footrest. Data is sent to the cloud after it has been collected. Using an API call, that is application interface, the server classifies the current sitting posture based on the most recent sensor readings using an SVM model that was trained with previously acquired data. As input dataset is huge, the accuracy of the model is 94.4%. The image processing software uses the angles formed by the lines joined with the key points and detects the wrong sitting posture of the user. When the back angle is less than 70 degrees, then the user is in the hunchback position, and when the back angle is more than 110 degrees, then the user is in reclined position. When the leg angle is less than 60 degrees, then the user is in kneeling position. The user's incorrect posture is notified in the form of pop-up message on the monitor screen. Conclusion and the future scope. In this study, the goal is to reduce users' back pain, which is brought on by prolonged incorrect sitting posture. In the first method, the SVM algorithm system supports the user to identify the bad sitting posture using signal from 4 sensors attached to the smart chair. The accuracy rate of this system is 94.4%. And the second method which we proposed in this paper is based on the image processing. Image processing is used to determine the poor sitting posture using a camera placed laterally. From the above information, we can conclude that the second method used in this paper is more efficient and accurate than the first method. In future, a chair that automatically adjusts to the user's height is something we can anticipate. Also, a chair that facilitates performing physical exercises like sitting bicycle crunches, oblique twists, triceps stretches, etc. could be created. So these are some of the references which we used for our project. And thank you everyone.